Optimizing resources is critical in deployment of generative AI solutions. This ensures that systems maintain high performance and remain cost-effective. Effective optimization involves selecting appropriate computational resources and configuring them for optimal performance and scalability. This approach involves managing resource allocation and dynamically resizing deployments according to evolving demands. Key objectives include efficient utilization of GPUs, management of compute clusters, and automated scaling to sustain workloads, thus providing a robust foundation for AI operations. Scalability refers to a system's capacity to adjust according to changing loads seamlessly without compromising performance. Azure provides several scalability options, including automatic scaling, manual scaling, and hybrid modes. Auto-scaling harnesses Azure's capabilities to adjust resources up or down automatically, guided by predefined metrics and thresholds. Manual scaling allows precise control, but requires active resource monitoring. Hybrid models combine both to offer flexibility. Strategic selection among these scalability paths ensures a resilient, adaptive AI system capable of reliably serving varying demands. Managing resources effectively involves comprehensively understanding the resource lifecycle within Azure AI solutions. Key principles include visibility, continuous monitoring of current usage and potential bottlenecks. Allocation efficiency, assigning resources accurately to match task complexities. Cost optimization, balancing resource type and expense dynamically. Predictability, anticipating changes in workload patterns through analytics. Applying these principles helps maintain performance consistency, optimizes costs, and contributes to system stability and user satisfaction. Scalable solutions in Azure AI benefit significantly from specific techniques, such as horizontal scaling, vertical scaling, and auto-scaling. Horizontal scaling, adding more instances of resources. Vertical scaling, enhancing capability by using more robust resources. Auto-scaling, automatic adjustment based on pre-configured rules and real-time metrics, CPU, memory, network traffic. By strategically using these scaling strategies, deployment can handle diverse workloads efficiently, maintaining efficient service provision even under heavy usage conditions. Azure provides powerful tools facilitating efficient monitoring and management of AI resource deployment. Azure Monitor, real-time data analytics, pain points identification, resource consumption tracking. Application Insights, performance diagnostics and analytics solution for real-time insights. Log Analytics collects telemetry data across Azure resources, creating analytical insights to optimize performance. Leveraging these tools enables proactive resource management, prompt issue identification, and resolution, thus enhancing deployment performance and reliability. Foundational model updates are integral to maintaining accuracy, relevance, and efficiency in generative AI systems. These involve periodic assessments and deployment of improved base models provided by Azure, such as those by OpenAI. They typically include stability improvements, new feature inclusions, and performance optimizations. Systematic deployment of foundational updates reduces technical debt and ensures staying aligned with latest AI advancements. It is crucial to establish criteria and a structured schedule for their deployment, factoring testing, user feedback, and compatibility validation meticulously. Automation simplifies the management and delivery of model updates in Azure AI, minimizing manual effort and enhancing accuracy. Use of Azure Continuous Deployment, CI/CD, pipelines. Automated testing through Azure DevOps, ensuring model integrity and functional correctness. Deployment gates to validate criteria fulfillment before production deployment. Automating updates optimizes operational workflows, reduces downtime, mitigates update-related risks, maintains projections integrity, and delivers consistent, reliable service availability. Optimizing resources significantly impacts cost management. Best practices in Azure include leveraging reserved instances to reduce costs substantially, implementing usage alerts and quotas to monitor and limit unnecessary expenditure, Regular review and adjustment of active resources based on performance metrics. Utilization of cost analysis reports within Azure Cost Management for informed budgeting. Careful implementation ensures cost-effective deployment that aligns with business objectives and operational efficiency. Structure organization of your Azure resources contributes to effective management and scalability. Recommended practices include organize resources into logical groups based on roles or locations. Implement resource tagging systematically for improved tracking and auditing. Separating production and development/test resources clearly to manage availability and prevent unintended disruptions. Such structuring fosters clarity, simplifies scaling of resources, streamlines monitoring, enhances security protocols, and supports compliance requirements, which contributes largely to an efficient and sustainable deployment environment. Version management in foundational models is crucial, maintaining version clarity and documenting version history comprehensively, ensuring backward compatibility or managed transition strategies. Rolling back capability guarantees rapid resolution if deployments encounter issues. Effective model versioning includes clearly defined workflows, rigorous validation processes for new deployments, clear impact analysis, and user communication strategy. Adopting these practices greatly reduces risk and ensures stable operations throughout multiple iterations of AI models. Applying scalability best practices in Azure AI entails continuous monitoring to promptly detect performance bottlenecks, employing predictive scaling whenever possible based on historical data patterns, choosing appropriate service tiers and resource limits, distributing loads using load balancers to avoid single points of failure. Incorporating these practices ensures resilience, meets user demands promptly, maximizes resource efficiency, reduces operational impacts, and enables effective planning for future system demands and growth. Despite substantial benefits, resource optimization and management pose several challenges. Complexity in scaling decisions, difficulty in predicting exact resource demands, risks associated with automatic scaling and foundational updates, including compatibility issues. Careful strategy planning, robust testing, and sophisticated predictive analysis contribute significantly to overcoming these challenges. Understanding and addressing them proactively strengthens deployment reliability, optimizes performance, and ensures smooth operation, benefiting overall organizational agility and customer satisfaction.